Hello everyone there. I am Archana of Sri Venkateshwara College of Engineering, Bangalore. I am pursuing my graduation in 6th sem of EC domain. Today, let's discuss about properties of Fourier transform. As we know that Fourier transform is the most of the time used in communication domain. So first, let us know about the digital communication. Digital communication is also known as the data transmission. It is the transmission of digital signal from one point to point channel. The digital communication is the use of online tools like email, social media messaging, and texting to reach other individuals or a specific audience in order to share a message. The block diagram of the digital communication is given in the picture. The most basic elements or the major elements of the digital communication systems are source, input transducer, source encoder, channel encoder, digital modulator, channel, digital demodulator, channel decoder, source decoder, output transducer, and the last output signal. Whenever we are discussing about the Fourier transform and the properties of Fourier transform, first we should be knowing what is Fourier transform and the applications of Fourier transform in different domains such as communication domain, mathematical domain, and in physics domain. The definition of Fourier transform in the communication domain is defined as the Fourier transform is a mathematical model which helps to transfer the signals between two different domains, such as transferring the signal from frequency domain to time domain or vice versa. Fourier transform has many applications in engineering and physics such as signal processing, radar, and so on. Let x of t be the time domain signal and x of omega be its Fourier transform. Whenever the continuous time domain signal x of t has been undergone to the continuous Fourier transform, it will exhibit x of omega, and the respected waveforms of Fourier transform is given in the picture. Now let us look after the properties of Fourier transform. There are about 11 properties of Fourier transform. They are linearity superposition, time scaling, time shifting, duality or symmetry, area under x of t, area under x of f, frequency shifting, differentiation in time domain, integration in time domain, multiplication in time domain, convolution in time domain. And the standard equations of Fourier transform is given as f of omega equals integration of minus infinity to plus infinity f of t e power minus j omega t into dt, and the inverse Fourier transform standard equation is given as 1 by 2 pi integration of minus infinity to plus infinity f of omega e power plus j omega t into d omega. Let us state and prove the properties of Fourier transform. Now, I am proving and stating any 6 properties of the listed Fourier properties. So, the first property is the linearity property. In the linearity property, the linearity of the Fourier transform is given as, let us consider the x of t as a time domain signal. When the two time domain signal when undergoes the Fourier transform, then it will states the linearity property. Let us consider x1 of t be the one type of signal and x2 of t be the second one of the signal. Therefore, when x1 of t undergoes the Fourier transform, it will exhibit x1 of omega, and x2 of t undergoes Fourier transform, it will exhibit x2 of omega. Then the linearity property is stated as a into x1 of t plus b into x2 of t. When undergoes the Fourier transform, it will exhibit a into x1 of omega plus b into x2 of omega, where a and b are the constants. The proof of the linearity property is when the Fourier transform is applied to the LHS of the equation, then it will execute integration of minus infinity to plus infinity a of x1 of t plus b into x2 of t whole brackets e power minus j omega t into dt. As we know that the standard equations of the Fourier transform, this process or this equation is being segregated as follows. And the final answer is given as a into x1 of omega plus b into x2 of omega. Hence, the linearity property has been proved. Now let us take the second property as time shifting. The time shifting is nothing but the shifting of time. In the time domain signal, let us consider x of t, as we know that when x of t undergoes the Fourier transform, it will exhibit x of omega. In time shifting, let us replace the t to t minus t naught. Therefore, the time shifting property is stated as x of t minus t naught when undergoes the Fourier transform, it will exhibit e power minus j omega t naught into x of omega. Proof: when the Fourier transform is applied to x of t minus t naught is given as integration of minus infinity to plus infinity x of t minus t naught e power minus j omega t into dt. Let us consider t minus t naught is equals to tau. Therefore, t is equals to t naught plus tau. Then the differentiation will be equated as dt is equals to d tau. And also the limits will be changed with respect to tau and t. Therefore, f of t x of t minus t naught is equated as integration of limits minus infinity to plus infinity x of tau e power minus j omega of t plus t naught into d tau. It is equated as e power minus j omega t naught integration of minus infinity to plus infinity x of tau e power minus j omega tau into d tau. As we know the standard equation of the Fourier transform, therefore the final answer is given as Fourier transform of x of t minus t naught is given as e power minus j omega t naught into x of omega. Hence proved. Note: when a signal is shifted time, a phase shift is introduced into its Fourier transform. The magnitude of Fourier transform remains unaltered. The third type of property of Fourier transform is frequency shifting. The frequency shifting is nothing but the shifting of frequency signal. We know that x of t when undergoes the Fourier transform, it will exhibit x of omega. In that frequency shifting, we should replace the omega, which is a frequency signal, to omega minus omega naught. Therefore, the frequency shifting is being stated as x of t into e power j omega naught t when undergoes the Fourier transform will exhibit x of omega minus omega naught. The proof of the frequency shifting is given as follows. When the Fourier transform is applied to x of t into e power j omega naught t, it will exhibit integration of minus infinity to plus infinity x of t into e power j omega naught t whole bracket e power minus j omega t into dt. Therefore, integration of minus infinity to plus infinity x of t into e power minus j omega minus omega naught t into dt. As we know that when the bases are same, the power should be added. As we know the standard equation of the Fourier transform, the whole equation is being given as x of omega minus omega naught. Therefore, the Fourier transform of x of t into e power j omega naught t is equated as x of omega minus omega naught. Note: multiplication of signal by a complex exponent in time domain corresponds to a frequency shift in the frequency domain. The fourth property of the Fourier transform is time reversal. Time reversal. We know that x of t when undergoes the Fourier transform will exhibit x of omega. When the time reversal is being undergone to the Fourier transform, it will exhibit as follows. Therefore, the time reversal property of the Fourier transform is stated as x of minus t undergoes the Fourier transform will exhibit x of minus omega. Let us consider or replace the t to minus t. Proof: Fourier transform of x of minus t is given as integration of minus infinity to plus infinity x of minus t into e power minus j omega t into dt. Let us consider t minus t to tau. Therefore, the differentiation with respect to t is given as dt is equals to minus d tau. Simultaneously, the limits will be altered with respect to t and tau. Therefore, Fourier transform of x of minus t is given as minus of integration of minus infinity to plus infinity x of tau into e power minus j omega of minus tau into d tau. Therefore, minus integration to plus integration x of tau into e power minus j of minus omega into tau into d tau. Therefore, by knowing the standard equation of the Fourier transform, the above equation can be written as x of minus omega. Therefore, x of minus t when undergoes the Fourier transform will exhibit x of minus omega. Hence, proved. Note, reversing a signal in time domain also reverses the Fourier transform. The fifth property of the Fourier transform is differentiation in time domain. The differentiation of time domain is stated as the differentiation of x of t by dt undergoes the Fourier transform will exhibit j of omega into x of omega. And the two times or the second differentiation of the time domain is given as d square of x of t divided by dt square will exhibit j omega whole square into j x of omega. The proof is given as follows. By the definition, the inverse Fourier transform is given as x of t is equals to 1 by 2 by integration of minus infinity to plus infinity x of omega into e power j omega t into d omega. Differentiating on the both the side will result the LHS and RHS of the statement. Therefore, the Fourier transform of d of x of t divided by dt is given as j omega dot g x of omega. Hence, proved. The sixth property of the Fourier transform is differentiation in frequency domain. Differentiation in frequency domain is stated as t into x of t, that is equated as j into d of x of omega divided by d omega. Proof. By definition, we know that x of omega is equals to integration of minus omega or minus infinity to plus infinity x of t into e power minus j omega t into dt. Differentiating on the both the side with respect to omega, the final answer will be given as minus j Fourier transform of t into x of t. Hence, proved. Thank you.